what quadrant to what quadrant does this one go? Go ahead.
2 to 1.
Q2 to Q1, right? So starting at Q2, and this side it goes to Q1. Do you understand what's happening there? Most people? No comment? Let's do another few more of them. Negative 0.1x to the 11. Okay, this one looks frightening, okay? What does x to the 11 look like? Y equals x or y equals x squared? Y equals x, okay? And it's a negative, so this is actually going to look very much like this one. Okay, because it's going to be negative and it's going to be even, looks like that. Okay, I'm going to do a bit of a note right now, so you can put this in your homework or in your notes right now. Okay, here we go. What is the end behavior for this one? There's two ways to put it. What's the one that number 7 used? What quadrant to what quadrant is this one going to be? I'm going to pick on someone at random, which is going to be Mackenzie, because you're up next. What quadrant, where does that go from what quadrant to what quadrant?
1 to 3.
I say 3 to 1, but yes, because you're going left to right. So this is going to be Q3 to Q1. So that's if you have a positive coefficient. Caleb, with me here? I just want you to get these down just to make sure so I don't have to go through this again, okay? So you're going a positive coefficient and then an odd exponent, all right? How you're good? Okay. Next, we're going to have a negative odd function. It's going to look, which is something like y equals negative x. Negative x cubed, negative 5x to the 5. All of those are negative odd functions. They have an odd exponent, but a negative coefficient. All right, Moses, I'm going to draw this on the board for you, and you're going to tell me what quadrants they go from, please. A negative odd function will look something like this. I can draw it properly. I'm going, Moses, from what quadrant to what quadrant, please? 4. Is it 2 to 4? I hope that's what you said. Q2 to Q4.
This can be negative.
Yes, they can, but not in this context. We're going to deal with only
Just
whole number
negative.
positives. Yeah, whole number positives are the only one we're doing.
Yeah, but what would they do to a graph?
Well, I'll show you in a second here. Because that's like number 7 I'll talk about.
Oh.
Okay, we're sort of feeling okay about this? Logan, how are you feeling about the world? A little bit better? Okay, you get the next question. Is everyone done with the left-hand board? Can I just get rid of it? I'm not. Thank you. We're going to do positive even function. Logan, you're getting a hard question from me today. Can you give me an example of a positive even function? Y equals what?
X squared.
Good. Another one would be?
X 4.
Good. Another one would be?
6.
Okay. Excellent. So I'm going to draw this as nicely as I can.
It goes like counterclockwise, right? Like the
Yeah.
upper right.
Yeah.
is to the left.
So these look sort of like a parabola, so it's going to be positive and look like a parabola. It's going to be something like this. All right? Kirsten, I'm sorry. Kirsten, what quadrants are those going to, please? From where to where?
Q to 1.
Q2 to Q1, very good. Now, is anyone unsure where this stuff is coming from? I want to make sure this is rock solid here. So I'm going to do one more picture. All right, and then we're going to be done. German tree for breakfast. Your brother's supposed to answer me right now. Here we go. The last one's going to be a negative even function. So this has a negative coefficient and an even exponent. So it's going to be y equals negative x squared, y equals negative 0.3 x to the 4th, or y equals negative 5 x to the 20th. All of those count because they're all negative coefficients, right? And they all have even exponents. All right, Regan, I'm going to draw this on the board, and you're going to tell me what quadrant it goes from, please. So this one's going to look like x squared, but it's going to be upside down. That's the only difference. All right, Regan, what quadrant does that go from what to what, please? 3 to 4, Q3 to Q4. Okay, so that was an addendum to your homework. You put that in your notes or your homework. I just want to make sure that's good. Now, you may refer to this page that I just did anytime you want, because this could be helpful for you when you're answering back and things, which we're going to be doing in the next few days. Okay? So this is called the end behavior. We don't know what happens in the middle of these graphs yet. All we know is at the end, the even functions look like x squared, the odd functions look like y plus x. Okay? And most people are sort of feeling sort of okay with that, I hope. Yes? All as well? All right, let's continue with the homework take-up. Is that okay for 4? Can I stop there? On 4, I'm going to skip the rest of 4, okay? Let's move on to number 7. Okay, they want to know if it's a power, exponential, periodic, or none. Okay, I'll do these very, very quickly here. Can somebody tell me what that graph looks like? If somebody give me an equation for something like that, just a general equation. Well, is it going to be positive or is it going to be open? Go ahead. Yeah, y equals negative x. I'm going to call it negative x cubed because there's a curve to it. The negative x to be corrected. Okay? So is this a power, an exponential, a periodic, or none? What type of function would that be? Rachel, go ahead. This is power. So it's just an exponent, right? This is a power function. Number B. This one hopefully looks familiar from last year. Charles, what is this graph going to be? Okay, does anyone recall what the equation of an exponential looks like? Yeah, I'm going to call it AB to the x, but I'm just going to call it 2 to the x or something like that. This one is one where there's a variable to the exponent. Okay, the exponential function. We'll get to these later in the course. This one I hope you've seen before too. I'm going to be particular on this one. Does this one look something like this? What type of graph looks like, Charles? I'm going to pass on you two right now. I appreciate your enthusiasm, okay? What type of graph is this? Power function? Definitely not. Exponential? Definitely not. Periodic. Now, I'm going to go even more than periodic. Can somebody give me an equation for this one? It starts at 0. Does anyone recall, Mackenzie? It is one of them.
Oh.
Science, right. This would be periodic. Okay? And if you don't remember sine and y, sine starts at the axis, right? Cosine starts at the maximum. Okay, we'll get to those a little later on in the course. Okay? Letter D looks something like this. Now this is a trick.
Brendan Howard to the main office, please. Brendan Howard to the main office, please.
This graph looks like this. Okay, now this one's tricky. What can somebody think of an equation for that? What would be the equation for that one? I don't know. What's a horizontal line? What's a... Go ahead.
Well, I'm guessing x is for like the horizontal, right?
Yeah.
So why don't it just be like x times something?
Sort of, not
I'm
quite.
just guessing.
Like x equals negative whatever.
Close, but no, it's going to be y equals negative whatever. Okay? Because if you think here, it's a negative 3, let's say. If it was x equals something, this is your x equals 2, your y value would be anything, right? So for this one, if x is 5, y is negative 3, if x is negative 2. What type of function is this? It's a constant for sure, yeah?
Power.
Well, I don't know, is this a power function?
I don't see an exponent.
Is that a power function? I'd probably call it a none is what I'd probably call it, okay? Did the back looks like power?
Yeah.
In the back looks at power, that's what they were thinking. X to the 0 is a power function, that's what they would have said.
I think the method book has made a couple of mistakes.
Yeah. If you were to call that none, I'd live with that in the test, right? Because there's no actual x's in it, okay? X to 0. Letter E. You guys haven't seen this one ever yet? It looks something like this. This is going to be what they call a logarithmic function. So this is going to be none. Okay? You haven't seen that one yet, so that's called logarithmic. Number F you have seen though. Oh goodness. That. You have seen this one in grade 11. Can I remember what that one with the equation or something that would look like? Jordan? Go ahead.
Something over like, we had an equation like 1 over x plus 5 or something.
Yeah, maybe something like 1 over x plus 5. What type of equation is that? Yep. This is rational, so nothing. Because that's not listed as one of the options. Okay? And the last one, hopefully, we got the everyone's favorite equation, grade 10. What does that look like to anybody? Parabola, so this looks like x squared. What type of function is x squared? Okay. Does that make sense where I got most of those answers from? Again, basically the whole idea about those ones, if you hadn't seen them before, it's supposed to be none. And this one sort of looks like an exponential, but it's actually the inverse of an exponential. We'll get to that later on though. So we'll talk about those. Yeah.
How can people discover this stuff?
It's miraculous. No, it really is miraculous.
Like,
math has increased so much in the last 500 years. Like the amount of power, like math is this watch that I have on now. The amount of power in this watch is more than a computer I had 20 years ago. Right? Or like in your iPhone, like that's miraculous. In your hand, imagine what's in there. That's amazing.
really,
Right?
just sometimes I wonder why we don't learn a little about history and math
Well, you probably could. They'd have me in university. It would be nice. Oh, I read about history and math all the time because I want you guys. So when are we ever going to use that? And I go,
It just help with the context.
which other one do you guys want? 8C? I don't see 8C. Am I on the wrong page?
H2.
Oh. 8C. Oh, yes. Grr. Mr. Faison, how are you? Are you looking for Charles Stanley? Because he promised me he'd compliment you, even though he's a favorite last time. Okay, who are you looking for? Even though she skipped Friday, you're still looking for everything to skip. Well, no, she was ill on Friday. Okay, can set her down. Please go back. So say to him that Mr. Sadler thinks he has nice shoes.
These nice shoes?
Yeah.
Okay, will do.
Unless he's wearing socks, then make something else.
I'll do both. I'll compliment both.
You always want guidance on your side. Okay, 8C. Okay, I'm going to leave this one. I'll write it on the board and tell you how to do it, but I'm going to do it very fast. I don't want to take too long. 1/4. Okay, I'm just going to go through it as quickly as I can, if you don't mind. So, what's the vertex of this? Vertex is going to be 3 and 5, and opens up. In order to get your roots, what do you need to do? In order to get the roots. Uh-oh. Quadratic formula, okay? So I'm going to FOIL it out. So it's going to be 1/4 x squared minus 6x plus 9. How would you find? Oh my goodness. 1/4 x squared minus 3/2 x. And this
It's
one?
negative 1/4.
Is it negative? Oh, sorry. Now, did you guys get nice answers in the quadratic formula or not? Okay. So what you can do is here, just sub in a equals, and I can't believe I'm going to say this.
Hey, you're using decimals.
Yeah, I know. Okay, so you can do that for this time. You can do that for this time because the quadratic formula is going to be messy. The way that I was going to attack this one is I was hoping you could do something like this. And then factor it. That's what I was hoping you would be able to do, right? So that's
Just so much easier when they're displayed as
Yeah,
decimals.
John,
Probably would you just multiply everything by 4 to get rid of that fraction?
well, because it's not, then it would be 4y equals, right? If it was equal to 0, right, then you could do that, right? But this is what I try and do probably, is I would go like this and try and factor it, and hopefully that would work out. Okay? You saw what I did there? Yes? Okay. Can I get to my lesson now? This class is going to be fast, okay? So stay with me. Here we go. Actually, this lesson's very quick, actually. Today's title is Characteristics of Polynomial Functions. Okay, in this course, I'll write it on here.
Should we copy down the English course?
Yes, please. We are concerned with and behavior. The number of x-intercepts. And the number of local maximums and local minimums. I will explain what those are with a picture. Okay. In advanced functions, we're worried more with it's difficult to find the local max and local minimums without calculus. That's what calculus is used for. It's one of the things that will help. But for us, we're going to graph with x-intercepts and then behaviors. The bumps we'll put in there in between. So here we go. Here's an example of y equals. This is going to be a cubic function as I'm drawing on the board. Okay, that is a cubic function. Okay. How many x-intercepts does this have?
2, 3.
3. Okay. So an x cubed function has a maximum of 3 x-intercepts. Okay. Can anyone see it being possible to have 2 x-intercepts? How would that graph have 2 x-intercepts? Anyone see? Can I go ahead?
If like the lowest value on the second curve was just touching.
Yeah, if it just like bumped like a vertex, right? Like just like how it is 1. Could it have 1 x-intercept? See Liam nodding his head? It could. What would have to happen, Liam, for that to have 1 x-intercept?
Everything is like shifted up.
Yeah, if everything was shifted up, right? Could it have none? No, it couldn't have none, okay? Because it remains going to be everything, so it can't have none. But it could have 2 and 1. Okay, this right here is called a local max or local maximum. This right here is called a local minimum. Okay, so if you take a look, if you look at the left-hand side of the graph, this is the local max is the maximum point on the left-hand side, the local minimum is the minimum point on the right-hand side. Now, of course, those aren't the overall maximum. What's the overall maximum of that graph? It's the highest point that graph can get up to. Infinity, right? Because it can go all the way up. But in between a certain spot, the local maximum is going to be, again, just the piece of the graph that's the highest in a certain range. That's the local max, okay? So for x cubed, there's going to be a maximum. Two local max min. I'm going to draw an x to the fourth graph, if you don't mind. And then we're going to go. Does this make sense, what I just drew there? Okay. That's what makes it an x cubed, you can tell, because there's 3 x-intercepts, so it's an x cubed, and two local max min.
Wait, so like there's only one max and one min?
Yeah, but there's 2 together, right? Like there's not, we're not distinguishing.
Okay, I thought that meant like, so there's 2 on each.
No, one, sorry, 2 altogether, right? 2 altogether, try that. Okay, let's do a quartic function. And I could draw these all day, but I'm going to stop after this one, okay? This is an example of a quartic function. Can somebody tell me, based on end behavior, why this is degree 4? It's going to be like x to the 4th. Okay? Why is it going to be degree 4? Go ahead, Charles.
Well, it's a parabola because it's an even exponent.
Right. If you look at the outside, that's parabola, right? Like that's the end behavior, like a parabola. Very good. Okay. How many intercepts do we have on this one? 4. Okay. So for x to the 4th, you can have a maximum of 4. And I don't really have to go through it, but you could also, depending on where you slide it, you could have 3 easily if one of these were to bump. You could have 2 if both of them were to bump right on the axis. And you could have 1 if it was all shifted down, right? And went down and then hit, and then down and then up. I guess that'd be 3, wouldn't it? Could you have 1? Yeah, I guess you could. You could have 1 if it went something like this. So it doesn't have to be balanced. Right? That would count as 1 x-intercept, right? Yep. You could also have 0 x-intercepts on this one. And again, people talk about error, okay? Don't say error. When you have a parabola, you don't hit the ground. That's like my daughter swinging on a swing and her legs don't hit the ground. There's nothing wrong with that. Or Spider-Man swinging through the sky and he doesn't crash. Like, that's a good thing. You don't mind that, yes?
What would you do the equation to make it that bottom one?
The equation for this one, we can play with whatchamacallit for a second, okay, right? But it'd be basically, it wouldn't be balanced, so it wouldn't just be like an x4, it'd be like an x4 plus, x cubed plus minus 2x squared. That could be a great big complicated thing. But the thing is, it wouldn't factor. That's the thing about it, okay? If it factors, it's going to look something like this, because you'll have all your different roots, like when you factor. But it would be something that wouldn't be able to factor if you like this. Okay. All right, how many local maximum do we have? Looking at this, I see this as a local min, right? I see this as a local min. And I see this as a local max. So for any functions degree 4, it looks like we have a maximum of 3 local, really what you call them local extreme points, what you would call them. And what that means is max min. Okay, does that make sense what I just drew there? Because I'm going to talk the general case in a second. Okay, we're going to draw a graph. Does that make sense, just from the pictures? And I could draw, sorry, go ahead.
Why is that extreme points?
Well, extreme point, other than max and min, it's called an extreme point. That's what it's called. Okay. But local max and local min is what I mean by that. All right, finally the general case, okay? When does this class end?
148.
Ugh.
Are we not making good time?
Now we're doing it.
So that's sort of like the exponent's coordinate, right?
Yes.
They always look like that.
Yeah. There's going to be a max of x-intercepts. And there's going to be n minus 1 extreme points. Just one sec, this is a comma.
Okay.
That means max and mins. All right, I don't remember where I stopped. I'm going to pick on my good friend Logan, okay, because I love your name. You want to do a wolf name of some kind for somebody on the show, guys. Logan, let's say I were to say to you x to the 10. How many x-intercepts could there be in a function with leading x10?
Two.
Nope. Think if there's x to the 10, okay? So what I'm saying is x to the 10, n equals 10, right? So how many x-intercepts are you going to have? Somebody help me, or he's writing. He's trying to write here. Go ahead. 9. Well, you have 10 x-intercepts because that's n is 10, right? And you have 9 extreme points. Okay. So 10. So whatever the thing is. So let's say I were to give you a function like this. Let's say I were to give you that function right there. You could have 5 x-intercepts. And 4 max and mins. Okay. Does that make sense? I'm saying that? That's what I'm saying, okay? If I give you a messy graph like that, and that's what I'm going to deal with in the next few days, how to deal with messy graphs, okay, you can find out the number of x-intercepts. So just think whatever the leading one is, that'll tell you. Does that make sense, Taryn? Good? You did eat breakfast this morning. I don't care to hear what you had, but you did have breakfast this morning. I'm glad to hear it. Okay, can I continue? Good. I'm going to pause in the video. The video is going to skip this last bit of the lesson, I think. How much time is it? 27 minutes.